Hello everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, today as according to the planner that I gave you regarding your chemistry exam that is going to happen on 28th, right? So today we are going to start with our preparation, right? So these power pocket videos are going to be very useful for all of you, right? So today we are going to start with inorganic chemistry, top questions of inorganic chemistry. By tomorrow I'll start with organic chemistry and I'll give 2 days to organic chemistry and then 1 day to physical chemistry, and then I'll do full power marathon, right, for your good revision. So let's start with the inorganic chemistry questions. All of these are your PYQs. Let's start with that. Okay. So first question is, which of the following characteristics of transition metal is associated with their catalytic property? Right. So if I want to associate them with their catalytic property, that is defined by variable oxidation states. Because they have variable oxidation states, that's why they are able to show catalytic property. Next is acidified KMnO4 oxidizes sulfite 2. Now what is sulfite? That is SO3 2 negative, and it will oxidize it to SO4 2 negative. So answer is going to be D is the correct answer, and that is your 2025 question, right? Okay. Next one is, let's see this question over here, and also do let me know in the comment section how many marks you got right. Okay, so let's see that. So if you see this here, while doing qualitative analysis in chemistry lab, Abhishek added yellow colored potassium chromate solution into test tube. Okay. He was surprised to see the color of the solution changing immediately to orange. He said that firstly you had yellow color of potassium chromate, right? Then it was changing to orange color, and definitely that orange color is of dichromate. He realized that the test tube was not clean and contained a few drops of some liquid. Now they are asking you, what is that liquid? So one thing you must know, that actually what happens, chromate gets converted to chromate gets converted to dichromate when you have acidic solution. So that means it must be an acidic solution, because of which chromate got converted to dichromate, which had orange color. So that means we are talking about acidic solution, that is D is the correct answer here. Again, this is 2025 question, right? Okay. Next is the correct order of increasing oxidizing power in 3D series of transition element. 3D series. So in 3D series, what exactly happens? If you talk about VO2 positive, this is going to be x minus 4 is equals to plus 1, that is x is equals to plus 5. In MnO4 negative, this is going to be x minus 8 is equals to minus 1, that is x is equals to plus 7. And what about Cr2O7 2 negative, that is going to be 2x minus 14 is equals to minus 2, that is 2x is equals to 12, that is x is equals to plus 6. So here it is going to be MnO4 maximum, then you will have Cr2O7 minimum is this, because of the oxidation state. So answer is going to be C is the correct answer, because of the oxidation states that we have. More oxidation state, more is the acidic strength. Okay, yes. Let's talk about the next question on your screen that we have. Copper if non-transition element. If copper is a non-transition element, is that correct? That is definitely false. Zinc, cadmium, copper. Zinc, cadmium. Copper was not. Zinc, cadmium and mercury. These are non-transition elements, right? Copper has completely filled d orbital in its ground state. Copper is Cu, right? It is 4s1, 3d10. So it is definitely completely filled. That is true. So A is false, but R is true. That is D is the correct answer here, right? Now let's see 2025 assertion reasoning question. That says which thing? Let's talk about that. It says CrH2O6, Cl2, and these are examples of homoleptic complexes. So homoleptic means which has same ligand. So they have same ligands, so it is true. All the ligands attached to the metal are same, that is also true. Because all the ligands attached to metal are same, that is why they are homolytic, so it is explaining it. So answer is both are true, and that is a correct explanation of assertion. Right? Okay. Clear everybody? Now let's talk about the next one. Next question here, that is, in the following groups are both ions colored in aqueous solution? Okay. Now he is saying, in which of the following groups are both ions colored in the aqueous solution? Okay. Now you have to see, colorless means it will be D0 or D10, otherwise it will be colored. So for copper it is 4s1 3d10, copper positive will be 3d10, right? That is definitely colorless. So it is not colored. If I see titanium, this is 4s2 3d2, then it is titanium 4 positive is definitely 3d0, again it is colorless. What about this? Cobalt is 4s2 3d7, it is 27, 4s2 3d7. You take out 2 electrons, it definitely has unpaired electrons, so this is going to be colored. What about iron? Iron is nothing but 4s2 3d6. You take out 2 electrons, it becomes 3d6. This also has 3 electrons, right? It is not empty, it is not fully filled, so that is also colored. So third and fourth are your colored compounds here, right? 2025 question, right? Okay, let's talk about the next one here, right? Just give me a second. Let's talk about this one, right? Okay, now let's talk about this thing here. Account for the following. Right now he is asking account for the following. Let's see. They are asking 3 questions here. This is how you will see a lot of repetition. Trust me, if you watch this lecture now, you are good to go for inorganic. Because if you have already done like theory part, this is like most repeated questions are asked in inorganic chemistry. Most repeated. You will now only see repetition of questions. Let's see. First is E naught value of this couple is much more positive. If I want to define it, if I want to define the first answer here, what I'll do, I'll just copy paste this, right? And I want to tell the first answer here, what I'll do here, right? I'll just, yes, this is what I'll do, and I'll answer this here, right? What you will have, see. You will say that Mn 3 positive to Mn 2 positive. This is reduction. Now we are saying it is positive. That means Mn 3 positive to 2 positive, it is easy. It is easy. Positive means this reduction is quite easy. Now if I say what is Mn? Manganese is nothing but manganese is, if I want to write it here only, manganese is nothing but manganese is 4s2 3d5. So manganese 2 positive is 3d5, manganese 3 positive is 3d4. So definitely going from 3 positive to 2 positive, you are going from, this is a stable state, this is half filled stable state. You are going from an unstable state to stable state, definitely that is going to be easy. That is why, that is the reason here, what we say that Mn3 positive to Mn2 positive reduction potential is positive because this is easy to go, right? If I talk about, on the other hand, if I talk about, this is how you write it in theory as well, the same thing that I am telling you. Now if you see chromium 3 positive to chromium 2 positive is, we can say, is less positive. We can take it as negative, that it is tough. That means chromium 3 positive to chromium 2 positive is tough. It is not easy. Now I am just layman language, I am telling you it is difficult to achieve. That means chromium is what? Chromium is nothing but chromium is 4s1 3d5. Chromium 2 positive is nothing but it is 3d4, and chromium 3 positive is nothing but 3d3, which is actually T2G, which is actually T2G3Eg0, which is a very stable state. That is why it is a stable state. This you will write why this is stable, because it is T2G3. That is why converting this into this, it is very tough. Here you are coming into stable state. Here you are going from a stable to unstable state. That is why this thing is tough to achieve. Right? Okay. Second question guys, second question is what we have here. Scandium is colored, whereas titanium is colored. Okay, now scandium and titanium, how do you write it? You will say scandium is what? Saktiv, Karman, Ficonicogen. So scandium is 21. It is 4s2 3d1. Right? So scandium 3 positive is nothing but 3d0. Now titanium is what? Titanium is 22. It is 4s2 3d2. So here titanium 3 positive is nothing but it is 3d1. Right? Now see this thing here. See this thing here. This is 3d0. That is why it is colorless, because there is no dd transition. No dd transition. This is what you will write. Why D0 and D10 are colorless? Because there is no DD transition. In this case, there will be DD transition which will make it colored, right? So this also done. Then there is the third question here, that is asking, actinoids are show wide range of oxidation state. Why? Why wide? Because their energies are similar. That you will see here only because of comparable energies of 5f, 6d and 7f orbitals. Simple. Then next is write the chemical equation for the preparation of KMNO for this pyrolusite. Pyrolusite ore. Pyrolusite ore. Right. Now for MnO2, what you have? You have KOH. Add KOH, you will get converted it into manganate. Then manganate in acidic medium is converted to permanganate ion that we have. Okay? Okay. Now let's see the next question here. Everybody, let's talk about the next question, 9th question. On your screen, that is, account for the following, right? Transition metals form alloys, and the second one is CE. Okay, firstly I'll say transition metals form alloys. Why? Because of almost identical atomic radii. That is the reason they are easily able to form the alloys. Because for alloys, they need to have identical atomic radii. Next is C4 positive is strong oxidizing agent. It is because C4 positive in the lanthanoids, the most common oxidation state is 3 positive. So easily it will be converted to 3 positive, because here decrease in the oxidation number is decreasing. That is why reduction is taking place. Because it itself is getting reduced, it will behave as a very good oxidizing agent. Right? Done. Okay. Next is done. Next is write one similarity and one difference between chemistry of lanthanoids and actinoids. Right? Similarity is both lanthanoids and actinoids show contraction and stable +3 oxidation state. It is both in lanthanoids and actinoids. Difference is lanthanoids are mainly non-radioactive, whereas actinoids are radioactive elements. That is why we rarely study actinoids. It's very difficult to study them, right? The next is complete the following reaction. You have Cr, you have dichromate here. In the basic medium, it is converted to chromate ion, right? This is dichromate, that is of orange color, and this is chromate. And you know the reverse happens when we add H positive, that we saw in the first question, right? That MCQ one. Okay, so these are highly asked questions from inorganic chemistry. See, inorganics 30 question I am teaching you and only 2 chapters are there. So you can see this is the maximum they can ask you in the exam. Right, so you're good to go, right? So CBSE, then we have CBSE 2024 question that is based on valence bond theory. Explain the geometric and magnetic character of NiCl4. Okay. So firstly, I'll explain that. I'll explain that here only, right? Okay, let's see. So guys, what you will have here, you will have firstly, so you will say that oxidation state is X minus 4 is equals to minus 2, that is X is equals to plus 2. So NiCl4 2 negative, here it is a strong field ligand. So nickel is nothing but it is 4s2 3d8 electronic configuration. Nickel 2 positive will be 3d8. Now what you will have, this will be 3d8. Now what you will do here, because this is 3d8, atomic number is this. Now this is a weak field ligand, this is D, this is S and this is P, right? That is the reason here what you will have, 8 electrons, so 1, 2, 3, 4, 5, 6, 7, 8. So it will be unpaired electron, 2 unpaired electrons, so magnetic moment is 2.8. You can also calculate it with the help of formula. Directly just 1 is 1.7, 2 is 2.8, 3 is 3.8, 4 is 4.9, 5 is 5.9. Okay, now this will be DSP, this is SP3. Okay, that is tetrahedral. So you can say geometry, it is SP3, that means it is tetrahedral. You can write tetrahedral. And here it is 2 unpaired electron, means it is paramagnetic. Okay, yes. Now next is draw the possible isomers of this one. Possible isomers of this one is, this is nothing but this is a bidentate ligand. So the one of them will be cis, where this is En, this is En, this is Cl, this is Cl. So this is cis, and other will be trans, that will be this one. Okay, but you know, cis will also have its non-superimposable mirror image, that is Cl, Cl, this is En, En. Okay, so these are non-superimposable mirror image and one of them will be trans. So this trans means En is opposite and this is Cl, Cl. It will have superimposable mirror image, right? So that is the reason what we say, cis will have 2 optical isomers. So cis has 2 optical isomer, means 2, and 1 is trans, so total you have 3. Okay, total you have 3 here, and the same thing is formed here. Cis is mirror image, but trans does not have any mirror image, right? Okay, next one is, next question guys, we have account for the following CBSE 2022 question, that is transition metal and their compound show catalytic activities. Again, how? Reason, variable oxidation state. Can I see that? Yes. Variable multiple oxidation state, ability to form complexes. They provide large surface area for the adsorption of the catalyst, and it utilizes N-1d and Ns electron for the bonding. These are the reasons, right? Okay. Second is zinc, cadmium, mercury are not transition because they have fully filled d orbital in the ground and excited state, right? Filled d orbital in the ground state as well as in the excited state. Next is zirconium and hafnium are almost identical atomic radii. Why? Reason is lanthanoid contraction. What is lanthanoid contraction? That is poor shielding effect of 4f orbital in lanthanoid. So what exactly happens in the lanthanoids? You have addition of 4f orbitals. Outermost electron is here. These are 4f orbitals and they are not able to protect the outermost electron from the nucleus. So attraction happens and they get contracted. That is why 4d and 5d series, they have similar radii, and that is the reason, because zirconium and hafnium, they belong to 4d and 5d. That is why they have the same radii. Okay? Yes. Next question, guys, we have CBSE 2024 question, that is, what is lanthanoid contraction and active? I just explained you lanthanoid contraction. Now they're saying actinoid contraction is greater than lanthanoid. Why? Okay, let's see. The steady decrease in atomic ion with increase in atomic number due to poor shielding effect of 4f orbital is lanthanoid. That I just explained you, right? Now, why it is more in lanthanoid? Why actinoid contraction is more? Because 5f orbital is even poor. 4f is poor. 5s is so poor that it will say 4f is saying this is nucleus, this is electron, I am closing my eyes, right? Okay, I can't see anything, right? This is like the brother, right? Brother of girl, right? This is the girl, this is the boy, and brother is like, okay, I don't know what is going on, right? And this is 4f. 5f orbital is like brother is saying, okay, you can go with him, right? Super cool brother, right? So here the poor shielding is so poor that electrons even get more attracted, and hence contraction is more here. Shielding effect of 5s is even poorer as compared to 4f, right? Next is, why do transition metal have high enthalpy of atomization? Which element 3D has lowest enthalpy of atomization? So large number of more the unpaired electrons, more will be the enthalpy of atomization. So large number of unpaired electrons in their atoms, their stronger is the interatomic interaction, and hence stronger is the enthalpy of atomization. And zinc has the lowest enthalpy of atomization. Highest, which one has highest? Vanadium has the highest. Okay? Yes. Okay. Now let's see the next one. Let's see the next question here. That is based on this question 2019 is purely based on the reaction part. When FeCrO4, that is your chromitor, is fused with this in the presence of air, it gives yellow solution of the compound A. That compound A is nothing but that is chromate. Okay, this is reacted with Na2 and it gives you sodium chromate. Then they are saying sodium chromate is reacted with H positive. Acidification give B. On acidification it gives sodium dichromate, which on reaction with compound B on reaction with KCl form orange compound, that is potassium dichromate. Okay. Now an acidified solution of compound C oxidizes Na2SO3. Now dichromate in presence of Na2SO3, it is converted to Cr2SO4. Right? Okay, this is what they are saying. Like, write all the compounds here. So these are the 3 steps of preparation, and this is the reaction part. Okay, chalo. Next is 2019 question again, that is, transition metals show variable oxidation states. Again, why this reason I have told you, third, fourth time it is being repeated in a different question. So that's why I am saying to you that in the different parts they ask you the question and some of them get repeated. E naught value of this is negative while that is positive. See, Zn2 positive to Zn is negative. That means Zn2 positive to Zn conversion is tough. Why? That means Zn2 positive is easy. Right? Here you have copper. Copper is what? Copper 2 positive to copper it is, while that of this is positive. That means this is easy. Positive means easy. That means Cu2 positive is nothing but it is 3D9 and this is 3D10 4s1. Now they are saying this value is negative while this value is positive. Why? Because if I say conversion of Zn2 positive to zinc, this is nothing but, what about this one? This is nothing but this is 4s2 3D10, right? Sorry, this is actually 3D10 and this is 4s2 3D10, or you can just write it here. This is easy because this is 4s2 3D10 and this is becoming 3D10. That is a stable configuration, right? Here it is being converted to a unstable. So Cu to Cu2 positive will not happen, and that is why the opposite one is easy. See, if I say this is easy, that means this is tough. It is tough. Why that is tough? Because this is 3D9 and this is 4s1 3D10. So definitely this is more stable. So conversion of this to this, it is very difficult, right? You just have to see which configuration is easy and accordingly you can answer. Okay. Higher oxidation state of manganese with fluorine is +4 and with oxygen it is +7. Directly your NCERT line that manganese has highest oxidation state of +4 in fluorine, but with oxygen it is +7 because with oxygen it can form multiple bonds. Okay, so you can say oxygen to form multiple bonds with the metal ion, whereas fluorine being small size and devoid of d orbital can't find multiple bonds. Exactly your NCERT line. And the above one also you can answer it according to the configuration. Okay, same thing I have written, right? Okay. Okay. Now next is CBSE 2025 question. Let's talk about that. Let's talk about that. Let's see if you can answer. See, in inorganic, you will see parts only, right? So here it is, the element in 3D transition series is this. Answer the following. Copper has exceptionally positive E naught value. Why? Because it has very high enthalpy of atomization and very low delta H hydration. That is the reason it has exceptionally positive value of E naught, right? Next is, which element is strong reducing agent in +2 oxidation state and why? Which is strong reducing agent? You have in +3 or +2 oxidation state. Wait a minute. In +2 oxidation state, see, chromium 2 positive to 3 positive, it is very easy. Why? Because chromium 3 positive, if I say chromium 2 positive to 3 positive, this is very easy. Why? Because it is this is 3D4 and this is 3D3. That is stable due to T2G3 EG0 configuration. So that is why it can easily increase its oxidation number. It can easily get oxidized. So it is a very good reducing agent, right? Accordingly. Zn2 positive salts are colorless. Why? Again, because of their Zn2 positive is nothing but it is 3D10. Because of fully filled d orbitals, it has no dd transition. That is the reason it is colorless. Okay? Chal. Next question, guys, 2019 question that says, 2019 question, guys, this is same as what we have done before, right? This is accordingly when MnO2 is fused with same question like K2Cr2, MnO2 is fused with QH in presence of KNO3, it gives dark color compound. That is what? That is manganate. So MnO2 pyrolusite ore with QH and O2, it gives you a manganate ion. After this, manganate ion in acidic medium is converted to permanganate ion, that is purple. Okay. Compound A disproportionate in acidic medium to purple compound, that is permanganate. Alkaline solution of permanganate, that is compound B, oxidizes Ki to a compound C. Ki. Acidic solution alkaline solution means Ki will be converted to very important iodate. But see, whereas acidified solution of compound B oxidizes Ki into D. If you have KMnO4 and you have acidified solution, then I negative is converted to I2. This is very important, right? That in the basic medium, Ki is converted to iodate, that is IO3 negative. But in the acidic medium, it is converted to I2. Okay? Done. Let's see the next one. Give reasons for the following. Transition elements and their compound act as catalyst, right? Transition elements and their, again, oh my god, how many times they have to repeat this question, guys? Oof. Right? Okay, that is done. E naught of this is negative than this. Right? See, same thing. If it is negative, that means Mn to positive to Mn. It should be tough. That means Mn to positive is easy. Why? This is 4s to 3d5 and this is getting converted to 3d5, which is a very stable state. But in case of Cu 2 positive to Cu, it is negative. This is positive. That means Cu2 positive to Cu, it is very easy. That means Cu2 positive, it is very tough. That means this is 4s1 3d10 and this is 3d9. It is not giving extra stability, so it is not possible to convert Cu to Cu2 positive. So here this oxidation potential will be negative, so its reduction potential is positive. Right? Okay. Acha. Actinoids show irregularities in the electronic configuration because of their very similar energies. Due to extra stability of empty, half-filled and fully filled f orbitals, they show irregularities in their oxidation states. Okay. Now, next one is, Acha, this na, how I am solving this, I am simply, if they have given me reduction potential negative, I'll say it is tough. Then oxidation potential will be positive and it will be easy. And I'll see why it is easy. There must be some stability, that is why it is easy. For you, it is quite simple. They have given you which is negative, which is positive. You just have to answer it. Just remember, if it is negative, this conversion should be difficult and the opposite conversion has to be easy. Simple. Okay? Yes. Now let's talk about the next question, that is CBSE 2024 question. Let's see that. How is the CFT crystal plane splitting of octahedral related to tetrahedral? So it is, you can say, wait a minute, where it is? So you can just directly define delta T is equals to 4 by 9 of delta O, that is the direct relation. Right, as you can see, all of them, there are how many parts? G parts. 4 here, 5, 6, 7 parts are there. Okay, so just write it in one word, they will give you marks for that. Write the IUPAC name of this one. So it is what? Diamine, ethylene diamine, right? Dichloro, that with platinum, and then the oxidation state you will calculate. See, simply how you will write it. You will just dichlorido bis ethane 1,2-diamine or ethylene diamine, platinum. Now, why it is oxidation status 4 here? See, why oxidation status 4? This is, you can say x minus 2 plus 0. This is plus 2. Okay. So, here it will be x is equals to plus 4. So, it will be dichlorido bis ethylene diamine, platinum, and this is nitrate. Okay. That's how you will write it. Next one is, write the geometry and magnetic behavior of NiCO4. NiCO4 is also quite easy. How you do it? See, Ni is 4s2 3d8. Carbonyl ligand is 0, it is neutral. So here oxidation state is 0 only. And here if you see D, and this is S, and this is P, total it is 10 electrons. So CO is a strong ligand. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you will be left with sp3, that is tetrahedral. So you can say it is diamagnetic and it is tetrahedral. Diamagnetic because there is no unpaired electrons here. So it is diamagnetic and tetrahedral. That is also done. Next is, what type of isomerism is shown by CONH? Whenever this kind of thing is there, it shows two brackets with exchange of ligands, that is coordination isomerism, right? Okay. Next is, for the coordination compound on the basis of crystal field theory, write the electronic configuration for D4 ion when this is given. See guys, when this thing is given, understand one thing. If pairing energy is more, kharcha is more, you have to spend more money, you will not spend it. You have less money in your pocket, you have to spend more money, you will not spend that money. Why? Because you have less money in your pocket. If I ask you to purchase something of 10 crores, you have only 1 lakh rupees. Why you will purchase that? You don't have that money. So pairing energy is more, that means no pairing will happen. So it will be 1, 2, 3, 1, 2, 1, 2, 3 and 4. That will be T2G3 and EG1. Okay. So they are saying, is the coordination compound high spin or low spin? High spin, because spins are there, right? And that will be the electronic configuration, right? And it will be high spin, done. Out of this and this, which complex is heterolyptic? Heterolyptic means different type of ligand. So this one is heterolyptic because it has more than one type of ligand. Draw the structure of optical isomers of this one. This we have already done. If you remember, this we have already done before also. That is, one will be cis will have its mirror images, and there will be one that is trans. They are saying only the optical isomers. So trans will not have any optical isomer, cis will have two optical isomers, right? That we have discussed before also. There they asked total number of isomers, so I told you 3. Here they asked only optical, so that is 2, right? Okay. Next question, guys. Let's see that. Let's see the next question here. That says, give reasons for the following. Transition metals are alloys. Again, same question that we did. That why? Because they have same sizes, very similar to each other, very similar. One metal can replace other metal to form lattice and form a solid solution. This solution is known as alloys. Then Mn2O3 is basic, whereas this is acidic. Why? Simple oxidation state. Mn2 O3 is 2x minus 6 is equals to 0, 2x is equals to 6, x is equals to plus 3. This is Mn2O7, this is 2x minus 14 is equals to 0, 2x is equals to 14, x is equals to 7. Okay, x is equals to plus 7. Now here it is plus 3, here it is plus 7. Now understand one thing here, if it is plus 3 and if this is plus 7 here, then more is the oxidation state, more is the acidic character. So this will be basic because of lower oxidation state, this will be acidic because of high oxidation state. Next is EU2 positive is strong reducing agent because easily EU2 positive can, because the most stable oxidation state of lanthanoid is plus 3. So it can easily get converted to plus 3. So there is increase in oxidation number that corresponds to oxidation. If it itself is undergoing oxidation, this will behave as a very good reducing agent. Okay, done. Done. So I have explained you all of that. You can just go through the theory part. I have explained you basically what to write it down. This is just a way of writing it in English, right? Okay, that's why I'll provide you with the PPTs, right? Okay, next question is, write down the hybridization and magnetic character of the following, right? One by one we'll do that. So if you talk about, this is how you can write it in the form of theory, but if you write it like this in the exam, they will give you 0 marks because the examiner will get irritated. So how you will solve it? You will firstly, wait a minute. Acha, this one I write it. I was thinking that why do they write it that way? Acha, I will solve it, okay? So for nickel, what you have, firstly write down the oxidation state of nickel. That is x minus 4 is equals to minus 2. That is x is equals to plus 2. So nickel plus 2 oxidation state is nothing but 3D8, and this is a weak field ligand. So here what you will have no pairing here. So 1, 2, 3, 4, 5, 6, 7, 8. So it will be paramagnetic with sp3 hybridization. Next one is this one, that is x plus 0 is equals to plus 3. So cobalt is nothing but it is 4s2 3d7. Cobalt plus 3 is nothing but 3d6. So in this case, what you have here, 1 NH3 ammonia is a strong field ligand here. So it is 1, 2, 3, 4, 5, 6. D2sp3. D2sp3. That will be the answer here. Okay? So answer will be D2sp3. There is no unpaired electron here. All of them are paired. So it is diamagnetic. Third one is this one, where iron is what, 26. So it is 4s2 3d6. This is x minus 6 is equals to minus 3, x is equals to plus 3. So iron 3 positive is nothing but 3d5. So when you fill the electrons here, in case of fluorine, there is no unpaired there is no pairing. So it will be 1, 2, 3, 4, 5, 6. So total 4 unpaired electrons. So it is paramagnetic, mu is equals to 4.9. Here mu is equals to 2.8 and here mu is equals to 0. Because whenever you have unpaired electron, you just add 0.7, 0.8 in the end, right? And here it will be sp3d2. sp3 and last one is d2 because of coordination number 6. So answer will be sp3d2 and paramagnetic is the correct answer here. Let's see the next question here. Shall we see the next question here? Let's see, guys. Let's see. E0, this manganese 3 positive. So if you talk about manganese, this is much more positive. That means this is easy. This is easy means manganese 3 positive to 2 positive is easy because this is 3d5 and this is d4. So definitely it is easy. That is why because you are getting converted to unstable to stable. Here it is difficult. Why? Because Fe 3 positive to 2 positive. That means the opposite one will be easy. 2 positive to 3 positive will be. 2 positive is 3d6 and 3 positive is 3d5. So it is here getting converted unstable to stable. So 2 positive to 3 positive will be easy and that is why 3 positive to 2 positive will be tough. That is why this is negative, right? Easy, tough, that's all you have to do. And this is a very highly asked question. Iron has high enthalpy of atomization than that of copper. Why? So iron has 3d6 4s2 outer electronic configuration. Copper has 3d10 4s1. You can see more unpaired electron, more the number of unpaired electron, more favorable is the interatomic attraction. That is why iron has 4 unpaired electron, has more enthalpy of atomization, because more the number of unpaired electron, more it is. Scandium is 3 colorless. Why? Because scandium is 4s2 3d1. Scandium 3 positive is d0. But titanium is 4s2 3d2. Titanium 3 positive is 3d1, which has dd transitions. dd transition means color will be there. Okay. Next one is CBSE 2025 question that says, what do you mean by chelate effect? Give an example. So whenever any bidentate ligand is there or more than bidentate ligand is there, they tend to form complexes like this. For example, they tend to form a cyclic ring, right? That is why when the ring is formed by the donation of more than 2 donating sites in a ligand, that forms rings and that is called as chelate. Okay? And chelates are more stable as compared to non-chelating ligands. Write the hybridization and magnetic moment. So here it is x minus 6 is equals to minus 4, x is equals to plus 2. See, iron 2 positive is nothing, but it is, I'll just write it here, iron 2 positive is 3d6. So if you see, this is 3d6, this is 3d, this is sp. Cn means strong field, means there is pairing. So 1, 2, 3, 4, 5, 6. So you have D2sp3 as the answer, and that is going to be diamagnetic because there is no unpaired electron here. So based on VBT also, they are very frequently asking you questions. PtCl2.2NH3 does not react with AgNO3. What will be the formula? See, if I say it does not react with AgNO3, that means both the chlorine are inside. This is according to Werner's theory. That means this is the formula. If one AgNO3 reacts to give AgCl, then I would say one will be outside because there is no reaction. That is why both of them are inside the coordination entity. Right? Okay. Next question, everybody. How is the variability in oxidation state of transition metals different from that of p block elements? Anyone? How is the variability in the oxidation state of transition metal different from that of p block elements? Because see, in p block the difference is more, +2 +4, like minimum 2-point difference is there in the oxidation state. In D block there is like continuous +2 +3 +4 +5, right? So you can write it in this way. In p block elements difference in oxidation state is low, in transition elements difference is 1. Okay. Next is out of Cu2 positive and this, which one is unstable? See, Cu positive is getting converted to Cu2 positive and Cu. That is why this is unstable, right? Because this easily disproportionates. Cu is unstable because it undergoes disproportionation reaction. Okay. Even though it has D10, even then it is unstable. Orange color, this changes to yellow when treated with alkali. Why? Because I told you, dichromate is stable in acidic medium, chromate is stable in basic medium. If you give basic medium, dichromate will be converted to this yellow means chromate. Okay. Then there is chemistry of actinoid is complicated as compared to lanthanoid. Reason being, chemistry of actinoid is why? Because they show multiple oxidation states, right? Respectively, which permits the formation of higher oxidation state through the removal of peripheral electrons. So there are so many oxidation states. Firstly, second is they are very radioactive and have strong propensity to form complex reactions because of unstable isotope, and that is why we are not able to study it properly. Okay. Yes. Then the next question, 2016 question, guys, let's talk about that. Mn shows highest oxidation state, that is +7 with oxygen, but with fluorine it shows highest oxidation state. This I have already told you, because of multiple oxidation state in oxygen. This we have already done, right? Manganese can form p pi d pi bond with oxygen by 2p orbital and 3d orbital of manganese, due to which it shows highest oxidation state of +7. With fluorine it cannot form these things, and that is why maximum oxidation state is +4, right? Okay. Next question is while studying periodic properties, Aarti came across abnormal behavior of hafnium. She found that even though hafnium is placed before zirconium, it has similar atomic sizes. Which phenomena is responsible for that? Phenomena is lanthanoid contraction. And we have already done what is lanthanoid contraction previously. Mention any other consequence of above phenomena. Other consequence of above phenomena is that there is decrease in basic character from left to right in the lanthanoid series, right? That is another consequence that appears because of lanthanoid contraction. Next is give reasons for the following transition metals exhibit catalytic property. That we have done like 3-4 times we have done the same thing. Fifth time we are doing this. Exhibit variable oxidation state, tendency to form complexes. Again, this is 2025 question that was there in 3-4 more years that was asked, right? So that's why I'm saying it's very easy to get marks in inorganic chemistry. Questions are so many repeated questions are there. Transition metals have high enthalpy of atomization because they have more number of unpaired electron, more is the enthalpy of atomization, that is the reason, right? So you can see this over here, due to involvement of n minus this electrons, which results in strong metallic bonding and strong interatomic bonding, right? Scandium is a transition element while zinc is not, because scandium is 4s2 3d1 and zinc is 4s2 3d10. Even in plus 2 oxidation state it is 3d10. That is why it has 3d10 electrons in the oxidation state as well, in plus 2 oxidation state as well, right? Okay. Acha. Next question is, the elements of 3D transition series are given as zinc, titanium, this. Write the element which has maximum number of oxidation state. Write the element which shows maximum number of oxidation states. Manganese will show you maximum number of oxidation states. Okay? Acha. This is direct question. Which element has highest metallic point? Highest metallic point. Which one has? Chromium has highest metallic point because of 6 unpaired electron in the valence shell, right? Next is, which shows plus 3 oxidation state very easily. So here answer is scandium shows plus 3 oxidation state because after losing it is getting converted to D0, which is a stable configuration. Last is, which element is strongest oxidizing agent in plus 3 and why? So manganese we have done in plus 3, easily it is converted to plus 2 because it is 3d4 and it is 3d3. Wait a minute. Oxidizing, na? Oxidizing agent means it itself should get reduced. So manganese to manganese. Wait a minute. Mn3 positive, if it is a very good oxidizing agent, it itself should get reduced. So this is oxidation number should reduce. This is 2 positive is 3d5. So we can see, it easily can get decrease in oxidation number because this is more stable. Because this is more stable, easily decrease in oxidation number can be there. So that means if it itself it is getting reduced easily, so it will behave as a very good oxidizing agent, right? Okay, done. Next question, guys. Next is, low spin tetrahedral complex are not known. Low spin tetrahedral, why? Because the gap is very less. Because delta T is approximately 4/9 of delta, that is approximately half. That is the reason low spin. That means because the gap is so less that the gap is so less that the electrons are always, see, if you have to go on first floor to third floor, you can easily go from the stairs, right? But if you have to go to from first to 14th, you can't go there with the help of stairs, right? You need lift. So that is why if the gap is very less, so you can easily jump to the next floor. So that is why if you can easily jump to the next floor, there is no pairing. So that means no pairing means high spin complexes will be required. Okay. So answer, you can see this over here, right? Orbital splitting energy are not sufficiently large. Okay. Cobalt, this is easily oxidized, so this in presence of strong field ligand. Why? Because cobalt 2 positive is nothing but 3d7. 3 positive is nothing but 3d6. So in presence of strong field ligand, why it is easily done? In presence of this, d7 is converted into more stable d6 configuration, right? Because D6 is a symmetrical configuration. If you talk about this, D6 is a symmetrical configuration. That is why it is more stable. Okay. What type of isomerism is shown by cobalt, this and this? So I can see it really that it is coordination. Why the solution of this is green while the solution of this is colorless? You can just write it down. This is x is equals to +2 and here it is x is equals to minus 4 is equals to -2. Here also x is equals to +2. But here you have a strong field ligand, right? And here you have a weak field ligand. So you can see this here. This has unpaired electrons, whereas this has no unpaired electron. This has unpaired electron. Why? Because if it is 3d8, you have weak field ligand, it will be 1, 2, 3, 4, 5, 6, 7, 8. So 2 unpaired electrons. In this case, it is 3d8, 1, 2, 3, 4, 5, 6, 7, 8. So no unpaired electron. So answer will be, I am just writing it for D5. Okay. This was also for D5. Okay. Then write the IUPAC name of following complex. Firstly, calculate the oxidation number. This is +0, this is +0, this is carbon dioxide, is it? So it is -2. So it is +0 -2 is equals to, this is 1, so it will be +1. So it will be +3. So you can say carbonato, and this is pentamine, cobalt. This will be 3. This is chloride. Okay. So answer is going to be pentamine, carbonato, cobalt, 3 chloride. That I just told you. Done. Just 2 more questions we are left with. Okay. Account for the following. 2-3 more questions, guys. Let's do it fast. Account for the following. The transition metal and their compound show catalytic. Again, I don't know how many times they are totally going crazy on that. 2022 also same. Zinc, cadmium, mercury are non-transition. Why? Because they have completely filled d orbitals in the ground and in the excited state. Zirconium and hafnium are identical atomic radii. Why? Because, ma'am, of lanthanoid contraction, repeated. Right? See, they are changing the parts here. The years are changing, and I have picked last few years questions. You can see I have not picked like 10-year, 20-year back. Last 5-7 years questions, and you can see repetition is on a high state. So you can now see PYQs matters a lot in board examination, especially in inorganic chemistry. Complete the following. You have MnO4 2 negative. In the acidic medium, this is converted to which part? This is converted to manganate. This is permanganate. It is converted to manganate. Green to purple. Okay. And now we have our last question that is based on the which part? CBT question, case based questions, right? Ma'am, do I have to read it? There is no point. It's a wastage of time reading this. Firstly, see the questions, then see the paragraph. Okay. You might not even need to see the paragraph. This is just an illusion that you need to see the paragraph. 1 mole of this precipitate 1 mole of AgCl. Okay, 1 mole, it precipitate 1 mole of AgCl means 1 Cl is outside when treated with excess of this. Write the structural formula. So chromium 2 Cl will be inside and 4 water will be inside. Okay, structural formula we have written secondary valency of chromium. Now how do you write the secondary valency? Secondary valency means coordination number. That is going to be 6. Okay. Primary valency means oxidation number, right? So, what is the difference in a complex and a double salt? See, a double salt like Mohr salt, right? What exactly? Potash, Lm. What happens? There all the ions are dissociated. Every single ion will be dissociated. But in case of coordination compound, the entities that are inside the coordination bracket will not be dissociated. So dissociate into simpler ions, while complex compounds do not dissociate completely into ions, right? Okay, next is arrange the following in increasing order of conductivity. See guys, according to conductivity, more is the ion, more is the conductivity. Here you have 3 ions, 4 ions, here you have 1 ion. So this will have maximum conductivity because of 4 ions, here 2 and 3 ions, here this is only 1. Because inside the coordination bracket there is no splitting. 3 plus 1, here it is 2 plus 1, here it is only 1. No dissociation. So more is the ions, more is the conductivity here. Is that clear, everybody? Do let me know in the comment section if that part is clear. So today was about inorganic chemistry. You can see the time here, it's already 12, and that's why you can see my energy was little bit on the lower side, because I was very tired and exhausted with all the classes that I have taken today. But I wanted to make sure that I provide you with all the needed videos, and every single video, the planner that I have shared with you, no idea how much hard work I am doing for you guys. I know that how much, this is 12, this is, what's the time? You can see this. What's the time? It's this much. You can see the time is 12. So I am really tired, right? But tomorrow I'll be recording some very important videos of naming reactions and distinguished test, organic conversions, right? That is going to be extremely important for you guys, right? So do watch it. Next 2 days are going to be completely devoted to organic chemistry. You will start your organic chemistry from tomorrow. Why I have taken this lecture today? Because I gave you this target to revise inorganic chemistry yourself. That's why these questions I have taken. Now I gave you the target of revising organic chemistry also, but along with that, my video of naming reactions, distinguished test, important reagents, organic conversions, and important organic questions will be there in next 2 days. So don't worry about that, right? So let's do it. Let's do it together. Yes, students. So I'll see you all in tomorrow's class, and spam it down in the comment section. Yes, ma'am, we are getting prepared for our exam, right? So see you all. Bye bye. Take care.